So I am about to do question number exercise 6.5. Question number 25. So 25, it says what? It says that show that the semi-vertical angle of the cone of maximum volume and of given slant height is tan inverse root 2. So what we see in here, so what are the things they have given? So they have given, what is given in here? So given is slant height is given. So slant height is given. Basically we take it as L, so in brackets I'm writing L. We have to maximize what? The volume. So the maximum thing is the volume. And what do we have to prove? We have to prove that the semi-vertical angle is tan inverse root 2. To prove that semi-vertical angle, let us take that known alpha is equal to tan inverse root 2. So these are the facts which are given in the question. So let us see what is the semi-vertical angle. So if I have a cone like this, now the semi-vertical angle is basically this one is my semi-vertical angle. Now, so this one L that is given, right? Now we know that the volume of a cone is what? 1 by 3 pi r square h. So when you look at the formula for volume, the formula for volume has r radius and height, but in here we have only slant height that is given. So what I will do is I will take, if I take this one as radius and this one as height, so we can express the radius in terms of the slant height. How we do that? Look, if I look at it here carefully, it forms a right angle triangle. The height, the radius and the slant height creates a right angle triangle. So if I say that height r by L is equal to sine alpha, so by looking at the diagram we can say that r by L is equal to sine alpha, because height by hypotenuse is sine alpha. So the radius is given by L sine alpha, right? And in the same way the height is given as what? Height of the cone is given by L cos alpha. So now we have found out, we know how to express the radius and the height as in terms of the slant height and the semi-vertical angle. So what we will do is we'll write the volume. Now the volume of the cone, so the thing which we need to maximize. So volume of the cone, in brackets I will write V is equal to 1 by 3 pi r square h, but I won't be using r and h. We'll be taking that L sine alpha and L cos alpha value. So what we have, 1 by 3 pi, r is what? R is the radius, so it will be L sine alpha whole square and L cos alpha. So if I write it nicely, we have 1 by 3 pi L cube sine square alpha cos alpha. So this is my V. V is equal to this thing, right? The volume of the cone. So basically we need to maximize this one, and we have to maximize this one. If I look at this expression carefully, the variable we can see in this expression is alpha. V is the variable, that's right. So alpha is the variable. L is given. Given means what? It's constant. Okay. So alpha is a variable. So obviously we have to differentiate the volume with respect to alpha. So what I will do is we will write here the expression V is equal to 1 by 3 pi L cube sine square alpha cos alpha. So we'll write differentiating with respect to alpha. So what do you get? dV d alpha is equal to, so it will be what? Now we'll use product rule, 1 by 3 pi L cube. So if I use product rule, what we have in here is sine square alpha, and differentiation of cos alpha is minus sine alpha. Then what we have is plus 1 by 3 pi L cube. So we have cos alpha, and differentiation of sine square alpha is 2 sine alpha cos alpha. So this is what we have. So basically we could have taken 1 by 3 pi L cube common. So what we have in here is minus sine cube alpha. This one is plus 2 sine alpha cos square alpha. So this is what we have. Now after doing this thing, what I will do is we'll try to find the critical point. So in critical point, dv d alpha will be equal to 0. So what we will do for critical point, dv d alpha is equal to 0. So what we have, 1 by 3 pi L cube minus sine cube alpha plus 2 sine alpha cos square alpha is equal to 0. So this is what we have. Now 1 by 3 pi L cube goes away. Now if I take sine alpha common from here, so what we are getting, now if I take sine alpha common, I'm taking sine alpha common, and what I'm doing is I'm writing cos square, 2 cos square alpha ahead, minus sine square alpha is equal to 0. So sine alpha also goes away. So what we have is, because sine alpha cannot be 0, because alpha cannot be 0. Why? Because how can, if semi-vertical angle is 0, then the cone will basically be like this. Okay, so alpha cannot be 0, so sine alpha goes away. So what we have, so this must be 0 in order the expression to be 0 is equal to 0. Now take sine square alpha that side. So what we have, 2 cos square alpha is equal to sine square alpha. So tan square alpha is equal to 2. Tan square alpha is equal to 2. Therefore tan alpha is equal to 1. Sorry. Yeah, it's right. Tan alpha is equal to root 2. No, sorry. I take back my sorry. So here tan alpha is equal to root 2. So now we prove that the angle tan of the semi-vertical angle is root 2. So we can say here alpha is equal to tan inverse root 2. So we got to this point. Now the problem is not complete in here. Why? Because my main problem is we need to now find that double derivative, and we need to prove that it is coming negative. Okay, so I hope that thing you will do it, and if you have a problem in that, so please show it to me as homework. You just have to do what? You have to find the double derivative of this expression. You just have to find the double derivative of this expression, and once you find d2 alpha d alpha square, so in place of alpha you will put tan inverse root 2. So if you see that one to be positive, then we can say that you cannot see positive, you will be seeing that one to be negative. Why? Because then only we can get maximum volume. Okay, so please differentiate this one and put the value of tan inverse. Achha, one thing, if you have a problem with this thing, so I will just tell you one thing, I will just give you 2 hints. So if tan alpha is equal to root 2, the value of cos alpha will be what? Look at here basically. Look, tan alpha is root 2. So we know one thing, sec square alpha is equal to 1 plus tan square alpha. So what we have in here? 3. So sec square alpha is equal to 3. So sec alpha is equal to what? Root 3. Right? Sec alpha is root 3. And once we get sec alpha is root 3, so cos alpha is what? 1 by root 3. So we got the value of cos alpha. Now if I need to find the value of sin alpha, what will be the value of sin alpha? We know how to find the value of sin alpha. It will be root over of 1 minus cos square alpha. So that is root over of 1 minus 1 by root 3 whole square. So that is equal to root over of 1 minus 1 by 3, and that is coming out to be root 2 by root 3. Root 2 by root 3. So the value of sin alpha we are getting is root 2 by root 3. So do one thing, So after finding d2v d alpha square, you will just put the values of cos, wherever you see cos alpha you put 1 by root 3, and wherever you see sin alpha you put root 2 by root 3. And what you will get a negative value. And once you get a negative value, then we can directly say that it proves that the volume is maximum. And the other question, so this is my question number 26. Now, question number 25. Now question number 26, look at here in question number 26, what we have in here is, show that the semi-vertical angle of the right circular cone of given surface area and maximum value is sine inverse 1 by root 3. So what is given in here? So given we have is surface area is given, and what is maximize? What do we have to maximize? We have to maximize the volume. And what is the proof we need to do? So we need to prove that semi-vertical angle is sine inverse 1 by 3. So we need to prove that alpha is equal to sine inverse 1 by 3. So these are the things what we need to do. Okay, so let's start with this one. So first thing, the cone. Again we are talking about the cone. So I hope in question number 25 we are very clear about the idea of this semi-vertical angle. So here what I will do is, we have the height here and we have the base radius in here. So this is my h. Now when we talk about the surface area of the cone, so what is the surface area of the cone? So it is nothing but S is given by there is a circle in there, pi r square plus pi rl. So basically it is pi r into r plus l, right? And what is L? L we cannot use, basically why? Because we try to write the expression of the volume or the surface area in terms of the perpendicular height and the radius. So in place of L I will write r root over of r square plus h square. In the previous question we were writing L because they have given the slant height. That's why it was far easier. Okay, so here what we see is that, so basically why am I doing in this rough? Because we need to have a clear idea. What we need to do is, we need to find the expression in terms of one variable. So when S is given, it means what? S is constant. So we have two variables, that is R and H. So we need to write we need to pick one variable and we need to express that one variable with respect to one other variable, so that we can write an expression which we will get in the future in terms of one variable. So let us see here. So we have S is equal to pi r square plus pi r root over of r square plus h square. This is what we have. So basically what we see in here, we'll try to represent h in terms of r. So we have S minus pi r square divided by pi r is equal to root over of r square plus h square. So first what I have done is that I have taken pi r square this side, then I have divided pi r. Okay, now if I square both sides, so what we have in here is S minus pi r square by pi r whole square. So we have r square plus h square, then h square will be S minus pi r square by pi r whole square minus r square. This is what we get. Let us solve this one. So the LCM we will have, it is what? Whole square. So pi square r square, we have pi square r square. So in the numerator we have S minus pi r square whole square, and in the numerator what we have is minus of pi square r to the power 4, right? So let us do the squaring of in the numerator. So if I do the squaring, what we have is S square minus 2 pi r square s plus pi square r to the power 4 minus pi square r to the power 4 divided by pi square r square. So basically you can cut these two and we can write this expression as S square minus 2 pi r square s divided by pi square r square. So what we see in here, that h square, I can write h square as s square minus 2 pi r square s divided by pi square r square. So basically we can replace h square by this thing, but you see we need to replace h. Okay, but if I try to find out h, there will be so many complicated things. There will be square root in there, then there is so many difficulty in differentiating this one. Okay, so what I will do is I will try to have an expression in which we can get h square, so that it will be more simpler. So what we have in here, so my half of the job is done. So this is the half of the job is done. So here what we'll do is, so I will find here the maximum, the volume will find. So volume of the cone is equal to, it is 1 by 3 pi r square h. Now that is what? This is V. V is equal to 1 by 3 pi r square h, right? Now we will do one thing in here. V square, V is equal to 1 by 3 pi r square h. V is equal to 1 by 3 pi r square h. Now you think, now let us say there is a function m. There is a function m which represents the square of the volume. M is nothing but v square. Now if v is maximum, then only v square will be maximum. If v is maximum, then only v square will be maximum, right? Okay, understood? So v square will be maximum when v is maximum. So finding where v is maximum is same as finding where v square is maximum, right? So what I will do is, we will square both sides. So squaring both sides. So by doing squaring both sides, we have v square is equal to 1 by 9 pi square r to the power 4 h square. Now you see, in place of h square, I will write this expression. I will write this one in place of h square. So what we have, 1 by 9 pi square r to the power 4. It is what? Let us see in here. It is s square minus 2 pi r square s divided by pi square r square. This is what we have after solving this one. Okay, so this is my v square we have. Acha, in place of v square, what I will write? We will write m. That one has a new function m. So m is equal to, let v square be m. So m is equal to what? So now let us cut something. So pi square goes out, and r square, this one will be r square. So 1 by 9 r square s square minus 2 pi r square s. So this is what we have, right? So what I will write in here, the maximum, I need to write something. The maximum value of m is equivalent to the maximum value of v. So maximum value, finding the maximum value of m is similar to that finding the maximum value of v. So let us find the differentiate this one with respect to r. So m is equal to 1 by 9. Let us multiply this one, r square s square minus 1 by 9 2 pi r to the power 4 s. This is what we have. So we will differentiate this one with respect to r. So differentiating with respect to r, what do we get? Dm dr is equal to, so we get 2rs square by 9 minus 4 by 9 into 2 pi r cube s. So we get basically, so if I take 2 by 9 r s common, so we have s minus, we have here 2 to the 4 pi r square. This is what we have, right? dm dr. Now we have to find what? We need to maximize this one. So let us maximize this one. So let us find the critical point. So for critical point dm dr is equal to 0. So what we have is 2 by 9 rs s minus 4 pi r square is equal to 0. This is what we have, right? So one second, let me just go through a bit. So this is what we have. Now what I will do is, now we have to find the critical point. So here the critical point, what we see is, we see s is equal to 4 pi r square. We see s is equal to 4 pi r square, right? Because this 2 by 9 rs, this goes away. So s is equal to 4 pi r square. So this is what we have. So I will write here s is equal to 4 pi r square. Now in place of s, we cannot use s. So in place of s, what we will write? The formula, what was that? The formula of surface area is pi r square plus 2 pi r n, pi r root over of r square plus h square is equal to 4 pi r square. So we basically have to write the expression in terms of h and r. So this pi square goes that side, so it becomes pi r or pi r root over of r square plus h square is equal to 3 pi r square. So this pi r goes, so there is only one r in here. So we have 3 r in here. Now squaring both sides, we have r square plus h square is equal to r square plus h square is equal to 9r square. This is what we have. Now r square goes that side, so h square is equal to, h square gives us 8r square, right? So this is what we have. So h is nothing but equal to, therefore h is nothing but equal to 2 root 2 r. This is what we have, but we don't need to find this thing. We need to find sine inverse. We need to find this angle, this alpha, right? So in order to find this alpha, we need to find what? Slant height. Let us find the slant height. We know h and r, right? So let us find the slant height. So one thing, what was the sine alpha is what? Sine alpha is equal to, look at here, sine alpha is basically r by l. So it is r by l is my sine alpha. So what I will do, let us find the slant height. So the slant height is given, l is equal to root over of r square plus h square, right? So that is how much we are getting. That is root over of r square plus h square is, you already know h square is 8r square. From here you see. So I will write here 8r square in here. So we get root over of 9r square. So we get what? 3r, right? So here, so we can find sine alpha. Therefore sine alpha is equal to r by 3r. So r goes away. So we have 1 by 3. Therefore alpha is equal to sine inverse 1 by 3. So we have found out the angle alpha, that is equal to sine inverse 1 by 3. Now for this question, let me do the second derivative test and find out whether the volume is maximum or not. So how to do that? So we have found out dm dr. dm dr is this one. Now you will be saying, sir, this one is easy, that's why you are doing. And you are 100% right. This one is far easier and faster to do, that's why I'm doing this one. So we have dm dr as this one, right? So we have to find second derivative test. So by second derivative test, what we have in here, so let me write this one in rough. So dm dr is equal to 2 by 9 rs, 2 by 9 rs s minus 4 pi r square, s minus 4 pi r square. So this is what we have as dm dr. Now we have to find what? d2m dr square by second derivative test. So let us just do this one. Let us multiply this one. So this is a square and this one is coming out to 2 by 9 4 pi r cube s. So now let us find out d2m dr square. So d2m dr square is given by, So this one will be what, 2 by 9 s square, and this one will come out to be minus this one is coming out to be 2 into 4, that is 8, right? So this one, let me erase this one and let's write that together as 8 by 9 pi r cube. So if I differentiate this one, so we getting 24 pi r square s by 9. So this is what we have. So what we are going to do in here is pi square, yeah, that's right. So let us see one thing. What we are going to do is, what we can do now, we have to put the value of s and we have to see it. So wait a second, let me just check this one. 3r square 24 s minus 4 or 2 by 9 rs, 2 by 9 rs, s minus 4 pi r square. Yeah, so we are getting 24 by 9. So we can cut with 3. Why we are confusing in here? So let me just write this one. So if I take 9 out, so we get 2s square minus 24 pi r square s. So this is what we have. So in place of s square, so definitely what we need to do is we need to write these values in terms of r and h. After doing that, we have to simplify and we will see that the value is coming out to be negative. Let me just do one thing in here. So if I take 2s common, so we are getting s minus 12 pi r square divided by 9. So the value of s is what? The value of s is pi r square plus pi r square plus h square. It will be negative actually. So we are getting 2s. So if we put the value in here, so we are getting pi r root over of r square plus h square minus 11 pi r square divided by 9. So it's coming out to be negative. If you look at carefully, if you compare these two values, obviously 11 pi r square is far more than this one. So we can conclude this one. So one second, let me just see. So in place of L we can use 3r, right? In place of L we can use 3r. Why we are going so pi rl? In place of L we can use 3r. So what we have in here, 3 pi r square, 2s, 3 pi r square minus 11 pi r square. So we are getting out to be minus 8 pi r square. Yes, we are getting it now. Now it's correct. So we are having minus 16 s pi r square by 9. So you see, since d2m dr square is negative, so the volume is maximum at sine at alpha is equal to sine inverse 1 by 3.